Okay, one of the questions that we've been asked a lot is why the shaking from this recent February the 22nd earthquake in Christchurch was so severe. And an obvious answer is that compared with the 7.1 back in September, this earthquake is actually much closer to Christchurch, and it's also at a shallow depth. But then people say, well, we had a 6.3 in 1987 at Edgecombe in the Bay of Plenty, and there's ground there that's similar to Christchurch, that's drain swamps and the like. Why on earth didn't we have the same amount of liquefaction and severe ground damage that we've seen in Christchurch? And the answer to this question is that this was actually a very punchy earthquake. Now, what I mean by punchy is it actually radiated a lot of seismic energy. Now, when we talk about the magnitude of an earthquake, what we're actually doing is measuring what happened on the fault. And in fact, what we do is we multiply the rigidity of the earth times the slip that happened during the earthquake, and in the case of the September earthquake, that was about 5 meters, and then we multiply that by the area of fault which slipped, and that gives us the magnitude. But what happens is you can have earthquakes of the same magnitude, but are actually radiating different amounts of seismic energy. Now, a good example is the Dusky Sound earthquake, which happened in July 2009 down here in Fiordland. And that earthquake had a magnitude of 7.8. That was a really big earthquake in terms of its magnitude. A lot of slip over a very big fault, and in fact it was the interface between the Australian plate diving under the Pacific plate. But that actually caused very little landslides and very little damage for the magnitude that it was. And the reason is that this is a very smooth fault which ruptures very often on the scale of 100 years or so. And what we find for those is that for their magnitude, they actually generate very little seismic energy. And we can measure this kind of how much energy that an earthquake is radiating by what we call an energy magnitude. Now, when we go back to the Darfield earthquake back in September, the magnitude of this was 7.1, but the energy magnitude was actually 7.4. So relative to its size, it was actually producing abnormally large amounts of seismic energy, which then translated to shaking. And the difference is even more extreme for this earthquake which happened on the 22nd of February. The magnitude is 6.3, but the energy magnitude is actually 6.7. And the reason we have this big difference is because the faults that moved both in the 7.1 and in the 6.3 have very high friction across them. And this translates into abnormally high shaking from these events. And the reason we have that high friction is because of the types of rocks that these faults are surrounded by. This really large amount of seismic energy, which was radiated from the 6.3 aftershock, is the reason we get all this damage in Christchurch. And this is reflected on our recordings of ground motion on what we call strong motion recorders. And here I'm showing 2 records from very close to where the earthquake happened, one at Heathcote Valley Primary School and the other at the Pages Road pumping station in Christchurch. And what you find with both these records, and in particular the Heathcote Valley one, is that the acceleration of the ground during this earthquake was 2.2 times the acceleration due to gravity. And in Pages Road, it was 1.9 times the acceleration due to gravity. So imagine if the ground is going up very fast and then it accelerates down faster than gravity. So the deeper part, the stronger part of the crust is going down faster than gravity, but what it does is it leaves the soil layers behind because they can't fall any faster than gravity. And these soil layers are actually peeling off, and this is what's called the Slapdown effect. And it's been only seen very rarely around the world because these are very extreme motions that we've recorded on a world scale. But of course, what happens then is that the soil layers just lose their cohesion because they're in tension, and all the water in those soils essentially separates out. But then of course what happens when the ground comes up again? It meets these soil layers coming down. And because water is highly incompressible, it's like a piston coming up and there's no gasket. This ejects all these liquefaction products that everybody sees through Christchurch. Much more so than in the 7.1 earthquake back in September, because in that case, the ground wasn't subjected to such extreme motions. So really the very strong shaking that we've had in Christchurch is a combination of a lot of effects, all of which have actually contributed to this extremely strong shaking and this extreme damage. Now, we know that this type of earthquake doesn't happen very often. We're talking about a cycle of maybe 10,000 years of that order. But essentially what's happened in this case is Christchurch has been in the wrong place at the wrong time.